A few months ago, just reading through some MSDN articles, I came across this concept of code contracts and started reading through it, and it just really kind of tripped me a little bit, got me interested, because one of the things that as a coder I have a lot of trouble with is you don't always protect your code very well. I mean, you write your methods and you're like, well, my method needs to add two numbers together. So you write that method and you don't bother checking the arguments to see, well, whoever's calling my method, did they pass me the appropriate parameters that I needed to execute this task? So code contracts seem like an easy way for me to start looking into ways to make that kind of coding easier. So we'll start off by, what is a code contract? First of all, it provides a way to specify preconditions, postconditions, and object invariance for a method or property. And I'll cover each one of these as I go through my presentation, make them a little more clear. What this kind of helps replace is, if you are actually a little bit better at programming than I am, you have what they call the if-then-throw logic. So when you enter into a method, the first thing that you're doing is you're saying, if my parameter 1 is not equal to null, then we can execute our code. Otherwise, I may throw some exception, like an argument null exception or invalid argument exception. So this can kind of help condense the code down, remove some of that logic. And we'll see later on as I get into the presentation that you may want to keep some of that type of code around depending on some of your design decisions. Lastly, code contracts provides a language-agnostic way to express coding assumptions in .NET programs. How many of you like to write documentation? All right, I got one hand. You don't count. Well, something that I found, especially as you'll see in my coding sample when I get to it, each of your methods, as you start to look through them and you see all the different code contracts that you've added in, you've pretty much documented the method very well. Anybody can come and look at that method and see these are the things that are required when I call this method, and here's what I'm going to get in return. So kind of in a way, your code becomes your documentation. So that's not a bad thing. So the first question that probably everybody's thinking of is, well, how do I use code contracts? Well, if you have the .NET framework installed on your machine, you have access to it. So you've already got step one complete. The contracts library is actually included in system.diagnostics. When I get to showing you my code project, you'll see that there's a new properties tab. Now, unfortunately, the current version of Visual Studio does not already have that integrated in, so you would have to install something from Dev Labs, which I've listed here, and at the end of my presentation, I've actually got a link to that install for you. There's two different versions of this Dev Labs software add-on, call it an add-on, and it's going to depend on the version of Visual Studio that you have. If you want to use one of the tools is called a static checker, and you'll need the premium version of the Dev Labs add-on as well as the premium or ultimate edition of Visual Studio to use it. Otherwise, you can just use the standard edition, which gives you the Runtime Checker, a little bit of static checker functionality, but not a whole lot. Code contracts does exist in the .NET 3.5 framework. All of my samples are in the 4.0, and just as things move forward, I just recommend that you just try to stay with the latest and greatest. If you forget to install the Dev Labs and you start to use code contracts, especially with the contracts requires with the T exception, which we can kind of see right here, you're going to get this assert failure when you try to run either unit tests or you actually try to run your program itself. So I just thought I'd put this particular slide in there just to kind of show, this was the first error I hit, and it took me a little while to figure out what was it I forgot to configure and what was it I forgot to do. So that'll kind of help out. The benefits of code contracts. Helps with automatic testing tools. Improved testing as you have designed the expected inputs and outputs for your method or your property. By having these cases defined, we can code our unit tests to validate all the situations and that appropriate exceptions are being thrown. So just by defining these code contracts, it's just going to make it a little easier for us to use the TDD methodology and create all the test cases that we need. The static verification tool, which is something that I'll be going over quite a bit in this presentation, checks over your code without actually running it and can actually make suggestions and give you warnings as to whether or not you're protecting your method properly. Reference documentation, I kind of mentioned that a little bit. One of the options with the project is that when you build a contract assembly, you can actually kick out an XML document that is supposed to contain all of your contract information. For some reason, I could never get this to work, so I won't be able to demo that today. And if anybody can ever figure that out for me, I'd appreciate the assistance. Writing cleaner code. Just kind of put this in there, going back to the if-then-throw logic. Some of the code reviews that I've had to do in the past, depending on how many parameters, you write a method that passes in a lot of parameters, you can end up with line after line after line of this if-then-throw logic. I think if we were to use the contract libraries, it would really condense that code down and still be very clear about what's required to run that method. And then lastly, provides guidance. So another coder comes along, wants to refactor this method a little bit. They've got a bit of pseudo documentation there to help them do that refactoring. So we'll kind of hit the first tool. There's actually two tools that are part of the code contract library. There's a static checker and there's a runtime checker. The static checker is probably the one that's going to give you the most information and is probably going to be used the most. As I said before, it provides warnings and messages about your contract calls. The nice thing about the static checker and the runtime checker is they are configurable at the project configuration level. So normally you have a debug release, and in some cases you may have created some of your own configurations for your projects. These settings are configurable at each of those different levels. So at the debug level, you can turn on all the options and have it take forever to compile, and when you get to release, you can just turn everything off and run with it. One thing that I did find interesting that I didn't see documented anywhere, but when I turned on static checking for projects that I had not put any contract code in, it actually gave me some warnings and actually searched out some of the code. The only thing I can think there is that there were some methods out there that actually had some properly formed if-then-throw logic, and when it saw those, it would officially check those methods to see if I had any changes that I would need to make. And again, to use the static checker, the Premium or Ultimate Edition of Visual Studio 2010 is required. Actually, I could probably flip real quick and show you, because our current setup, we have the Professional Edition, and I'm not trying to get on you here, but this is not my laptop. But we can see right here with the static checking, this is not included in this version of code contracts. It does give you a couple options though. It gives this cache results and this implicit enum write obligations. What the implicit enum write obligations actually does is it just looks through your code, and anytime you're assigning a value to a variable that's an enumeration, it'll make sure that what you're assigning matches one of the types defined for that enum. Now, if you did have the full Premium or Ultimate Edition, here's what the property page would actually look like. We can see that the assembly mode drop-down actually has either a standard contract requires or has a custom. For some reason, it defaults to custom, which means that it's expecting you to provide a custom contract assembly with your project. But when you're just getting started, first thing I would do is I would come in here and change this setting to standard, because you're not going to have a custom contract assembly to include. Take note that this will show you which configuration these settings are actively applied to. In my case, I'd created a development configuration, so my settings are applied to it. And this contains all settings for the runtime checking, which we'll get to here in a little bit, and the static checking. First option, perform static contract checking, just turns on the whole thing. And when you compile, it'll actually run through its logic to statically check your code. A little footnote with that, it is very slow depending on what options you have turned on. Some of them with checking the background, it's going to determine if the static checker is going to block your build, or if it will actually allow you to build without doing the static checking. I think by default this might be off. Some of the implicit options, the non-null obligations, these warn about potential inappropriate uses of null in your code. Implicit arithmetic obligations, I think that's one might be a little obvious. It's looking for divide by zero errors or floating point precision mismatches. And I've had a lot of issues with that in my code, with grabbing data from different sources. Sometimes, 5 decimal places here, 4 here, so these might help, detect some of that stuff for you. Array bounds, again, if it knows what range, make sure that you're not trying to access something outside of the range, or not trying to initiate an array with a negative size. Redundant assumptions causes the checker to attempt to prove any contract.assume statements. If you check this particular one, it really slows down the build, and it's recommended that you don't use this option unless that's what you're specifically checking for. And then we went over the implicit enum write obligations. It's got a little warning level. By default, it's set to low, so it's a matter of what types of, or how many warnings do you actually want to see as it runs through its analysis. So the first thing we'll look at when we look at our methods are preconditions. I'll just stop here. If you guys have any questions I'm going along, please feel free to interrupt me, and I'll do what I can to answer you. Preconditions allow you to define conditions that must be yet to use your class methods or properties. There's a few different ways to do this. You can leave your if-then throw logic in your method and just put a contract.end control block at the end of all of that code. What that'll tell the static checker is that everything above this particular end contract block is something that it should check and try to validate for your method. Or if you decide that you don't want your if-then throw logic in there, you can replace it with the contract requires or the contract requires T exception. I put a little asterisk next to the T exception one because this guy comes with a warning. If you're going to use contracts.requires that's going to throw an exception, when you go to release, you have to make sure that you turn on the runtime checker. If you don't, it will try to, if there's a failure, it'll try to assert and throw up a message box, which depending on, if it's a shared assembly or if it's a service, that's not a desirable thing. So be a little wary if you use the contracts requires T exception. So we'll jump into a couple examples here. These are just some of the warnings that you can get from the static checker that deal specifically with preconditions. The very first one happened to be something where when I first started out, I had a method, I stuck a requires on there, and everything was working just fine. And then as I was doing some of my unit tests, I said, well, I've got a dependency problem, so I need to create an interface. So I created an interface for this class, and the next thing you know, I'm getting this warning. I didn't really know what to do with it. Well, turns out that when you're putting in your requires, you need to make sure that that particular contract is at the highest level that it can be. So in this case, since this class was inheriting from an interface, we needed to actually put those contracts on the interface itself. And of course, I know your first question is, well, how do I do that? I'll get to that later. That's a little teaser, by the way. So, some of these others, contract requires, it's unproven, and it would throw out different stuff, constructor, source, outer, inner. What it was picking up on was that I was trying to say that one of the parameters coming in to my method, I want to make sure that it's not equal to null. It was kind of saying it was unproven, and what that is basically saying is I'm maybe not putting this particular contract at the highest possible level that I can within my class. There is a chance that maybe even if it is at the highest level and it's still giving that, we can use the contract.assume to kind of ward off the static checker a little bit and say, no, it's okay. I know what I'm doing here, and he won't be null. And then one of the other ones I saw, it actually popped up on a data set access, where it was accessing a particular index within a data set, and I think because I had the array bounds turned on, he couldn't determine if I was actually accessing something properly, so he was telling me there's potential that you're accessing something that would be a null reference. So, figure a little humor. Some of you old C programmers might recognize some of that code. So, kind of flip to our demo here a little bit. So what I've tried to do is I've tried to kind of throw together a quick little calculator class. Just has a add method to him. I won't accept negative numbers. Everything has to be positive. So it's a positive calculator. We'll just put it that way. So what I've got here is I've got a couple different methods. I wanted to show the code first. You didn't see that. I wanted to show the code first before we actually would insert some of our code contract logic. So we would come in here and, hey, if operand 1 is less than 0, I want to throw an argument exception that says the first operand cannot be less than 0, perform the same operation on the second operand. So you can kind of see, we're looking at, 8, 9 lines of code before we even actually execute the actual meat of our method. Now, if we wanted to stick with the legacy way of doing things, what we could do is we could actually add contract, end of contract block, and that'll tell the static checker that everything above that block is actually a precondition that needs to be checked. So how can we clean this up a little bit? Well, how we can clean this up is we can add in 2 requires statements right here. So contract requires, he's going to throw an argument exception if the operand, well, you put in the positive check here, so you're basically saying I require that operand 1 be greater than or equal to 0. And if that happens to fail, then he will throw an argument exception. So one of the first things that kind of appealed to me was we basically took 8 lines of code and we've condensed it now down to 2 lines of code. And then we can see as I went farther in, even some of the post conditions and stuff, which we'll be coming back, you can see there was actually some requires that I missed. So what that would kind of indicate is that in my add old method, there's actually some checks that I'm missing. So there is potential that this particular method could blow up if the wrong, even if positive operators were passed into me, then I have potential problems. Have any questions so far about preconditions? Sure.
In the add method, contract requires, then you have the requirement and the argument, and then the generic is the exception you want to throw.
Yeah.
Where does it get the message from? Is it a standard message?
Since I didn't specify one, it would be a standard message, but actually there is an overload for this, so that I can define if I want to put in my own user message, I can. But it's not required. But yeah, I mean, you can put in something to say, hey buddy, you need to. I mean, probably similar to what I did up here, where I could actually stick
if
it.
You don't put one in, does it? Because when you throw up an argument exception, a message is required, obviously. There's none. So what does it do if you don't put one in?
Pretty much, from what I saw when I actually ran this, it gives you just like a generic precondition failed, and then kind of gives you the tries to tell you what it was that actually failed. So actually. Whoop. Yeah, I shouldn't have put in my, there we go. Yeah, so we get basically an unhandled exception in that case. Pretty generic message, contract. In this case, it says invariant fail because I've actually got an invariant method hooked up to it right now, but I'd be willing to play around with that a little bit after the presentation if you'd like. Yeah. I saw that you could add a message, but I really didn't play around with it for the demo. So, any other questions before I go on? Okay, great. Either I'm doing a good job or you guys are just falling asleep, one of the two. So I'll go with your falling asleep. How about that? So, post conditions, pretty much just it'd be the opposite of a precondition. I'm assuming everybody can figure that out. This is kind of a way that, if you think of a contract, it's basically, if you give me this, I promise you that. And that's what the post conditions are going to help us do. It's going to allow us to promise the user that if you met all my preconditions, I promise you that I will give you a result that's greater than 0, that it's or positive or not null or whatever design decision you want to make for that particular method. How we accomplish that, some of the other methods in the contract library are the ensures, and also the ensures where you can throw an exception. There's a couple different ways to use the ensures. You can use it with another contract call for contract result. So if the result hasn't been defined yet, you can kind of generically say, well, contract.result, give it a generic, like in our case it would be an integer. So I'd put in an int, is greater than 0. So you don't have to have your variable defined ahead of time as far for what you're going to store your result in. The other way you can do it is you can actually just put a Boolean expression in there. So in the case of my add function, we go back to the sample. Well, for the ensures, I can either say contract.result, or I can say that operand 1 plus operand 2 is greater than 0. Either expression would be just fine. Something, the nice thing I found by doing post conditions, the static checker actually popped up and told me something I was missing that had not appeared before when I was doing the preconditions. So this kind of just, for me, kind of drove home the importance of when you write your methods to really think about what do you want to accept and what it is that you actually want to hand back to the caller. So, because, I mean, at least in this case, it pointed out something, a precondition, something I needed to make sure that I required before my method would be called. So just a quick example showing that the ensures was unproven, and actually this is the warning, this was the nice little helpful warning that I got that told me, well, you didn't quite prove your post condition, and right above it was actually another code contract warning that told me, but if you add this requires, you'll take care of this issue. So kind of in a way, he kind of helped me along. So with the post conditions, so I've got the ensures for the contract result for the integer, and I want to make sure that he's actually greater than 0. we could probably see a slight flaw in my logic, because I think he has to be greater than or equal to 0. Now, when I actually ran this through the static checker, he actually popped up and told me, since this is unproven, if you add in a contract requires operand 1 plus operand 2 is greater than 0, then I'll make this warning go away. So that was actually very helpful. Have any questions about post conditions? No? Okay. You guys are making this too easy for me. Object invariance. This was a topic that actually, when I got to it in the MSDN articles, I kind of realized it was something I really didn't think a whole lot about when I developed my classes. Object invariance basically defines that after a set of operations, that a particular condition in your class will still hold true. So in the case of my calculator class, I decided, you know what, I'm not going to let you add numbers that the sum is greater than 10,000. So, and then I'm storing the result in the class so it can be accessed later on. So basically what this is saying is that when it stores that result, it must be 0 to 9,999, because I don't think I included 10,000 in my bound. So when you're designing your class, you might want to try to think about these kinds of things. You know, is there a particular property, some kind of state with my class that I don't want, that shouldn't change or stay within a certain bound or a certain range? So what we do then is within our class, we actually add in a method that will contain some contract invariance calls, and this will help us define the invariance for our class. And this gets into some of the attributes that can be used with code contracts, and we'd specifically be using the code contract invariant method. So now I'll run off and demo here. So what I've done here is setting up a method, contract, and using the attribute contract invariant method. Now what I found was, I don't think the compiler screamed at me a little bit, but it was recommended that, you know, since this is a method that we don't want anybody outside of our class calling, that we would want to make it a private method. And since it really doesn't execute any code, we're going to, you know, it's not going to return anything, and then the name of the method doesn't have much bearing. So then using the invariant calls, I'm able to define my particular result variable within my calculator class is defined that he can be greater than or equal to 0, but he must be less than 10,000. So actually, I don't know what I've changed. Let me build. And this was actually what I just ran a second ago, where I could show that because, actually I'll show you my print, just went out of order there. My actual main program, I knew up my calculator class, and I say, hey, let's add 5,000 plus 6,000. So, yeah, 11,000. Quick check. So that's going to be outside my bounds, so then actually, you know, debugging, running my application, he's going to come back and assert that I've failed. I've changed the state of the class outside of the bounds. So, any questions so far on that? Sure.
Is this a debug only thing, or is it debug and release?
No, this is something that you can, I mean, you can have an invariant method for your release. I mean, as far as the static checker piece of it, you know, for release, you'd want that turned off. But yeah, the invariant methods you would define. Actually, I do not remember. You've got me curious now. I don't remember if it had. No, he did not have a generic on him. I was wondering if he had a generic on him to throw an exception if it went outside the bounds. So
I have a question on this. Is this the way you would do it normally? Just have a void method? Is this
yes.
So basically, all that would ever be in there is contract.invariant and whatever you're trying.
Yes, because you use the contract invariant method attribute. If you were to put any other code in there, it'd just get ignored anyway. The runtime checker is what's going to walk and evaluate these invariants and actually then update your MSIL code.
Oh, wow. So if you had like 3 of those, if you had result range 2, 3, 4, does that mean that the MSIL for int add would implicitly have a call to all of those after every call to add? Could you be using it? Does that make sense? Or I'm trying to understand how it would flow as far as at runtime. Linking into his question about whether it would run and debug and whatever.
Right. I think what I found when I was testing out the invariant stuff, because I actually see the other commented out requires the static checker. Since he saw these invariants, he actually came back and told me, he's like, again, nice little helpful messages to say, well, you should add some more requires then to your method to keep it from violating these invariant calls. Yes.
Sorry, so this code never actually runs ever, right? That result range will never actually get called. That's only in the code for the static checker, right?
It helps the static checker, but
like during runtime, you'll never hit that.
No, there's no,
Like,
there's no code that's
actually, I mean,
well, so if you look at the breakpoint there, it would be impossible to ever hit that.
well, I can tell you what we did. I don't remember. I want to say that he checked through it, but there we go. That's not good. No, I killed it.
Is it doing the static check in the output right now?
Well, I haven't seen the static checker take this long with it. I mean, the size of my project is so small that, I mean, static checker's never taken very long to actually process this. I thought so. Well. Doesn't look like there's something I'll be able to prove at the moment. Yeah, the special demo here. So. I'd be willing to try to run through that again later. I'm trying to remember because I stepped through, tested the invariants. I mean, actually when I ran my code here, he actually threw a specific contract runtime error about saying the invariant failed, showing that this result was not less than 10,000. But then when I actually put in the precondition actually caught it before it would ever hit the invariant piece of it. So, yeah, I'm thinking after. So I think it's better maybe if I don't have a precondition in there, the invariant code is going to get inserted somewhere because of the runtime checker. So because I mean, one way or the other, he's determining that I went outside the bounds of.
You said the runtime checker was configurable. You could say whether to include it in the release build or whether to not.
Correct.
Okay.
Correct.
So basically, it's up to you whether you.
Right. So if you were to turn off your runtime checker, then your invariant method would.
Is that what they would recommend? What's the recommendation or the standard? Is it mainly just for testing, get it up and running, make sure it passes testing, and then strip all that stuff out?
The only recommendation I really saw with the runtime checker was they just warned about not to turn it off if you were using the requires that throws the exception. You did have to have that runtime checker turned on for that case.
So you have to deploy to production if you wanted to use
with the runtime checker, yeah. If you were using that particular requires. Otherwise, I didn't really see any recommendation as to we write, you should use it, not use it. It just seemed like it really came down to design decisions and stuff. Actually, I do have a chart later here in the presentation to kind of help make that decision. So, any other questions before I move on, or we'll kind of put a pin in the one. We'll see. We'll try and run a couple samples, see what we can find later. Well, I promised I'd get back to it since I mentioned interfaces, so here we go. Using code contracts with interfaces. Basically, we know that interface basically just kind of defines your properties and your methods that would need to be defined if you were going to inherit from this interface. So basically, for code contracts, what you need to do is basically create a buddy class, they call it, to go along with this interface. And there's a couple attributes then that you need to set, which I've got a nice little sample for everybody to see. There's a contract class attribute, and then there's a contract class for attribute. So it's kind of a, when you define it, and I kind of look at it as it's kind of like a, I want to say double handshake. That might not be the right way to put it, but on the interface he says, hey, I've got this class that's going to define my contracts for me. And then when you go to that class, he basically has an attribute that says, I'm the class for this interface. So we can make sure that things are getting matched up properly. And the buddy class is actually, can be an abstract class. I think they even said you could actually create a class and seal it, and that would be acceptable. You didn't have to make it abstract. But for my purposes, I went ahead and just, initially I forgot to make it abstract, and he yelled, the compiler actually threw an error on me, yelled at me because of the attributes I had set. So. So basically what I did here, just for demo purposes, I created a demo interface, and I just stuck one method in there just to, hey, just check to see if what I passed in to you is a string. Probably should have maybe called it empty string after how I defined the actual method. Put the attribute on there to say, hey, I have code contracts. My contract class is type of demo. So somewhere in this namespace, we should hopefully find a abstract class or a seal class called demo that inherits from that interface and contains that contract class for, that basically says, I'm the contract class for that interface. And then he will actually implement the interface, and then you can stick in all your code contract logic. This takes care of that one precondition warning that we were looking at earlier, where I had a requires actually in the method that was part of the interface, and he said, whoa, you need to actually move that contract up to the higher level. So that's what this would actually accomplish for us. Something to note here is, my isString is supposed to return a value when you actually implement this. Well, since this is just an abstract class, this is just for the purpose of code contracts, we can either just return like a default for that data type, or we can leave in, when you implement it, it always throws in the not implemented exception. It's perfectly fine to leave that in there because that particular code is actually not pulled in by the runtime rewriter. So, but I'll show you, if you're actually to comment that out, then you're immediately going to get an error here. See the red squiggly under his string saying you're not returning a value. So it seems kind of weird to not return a value to put that in there, but it's perfectly okay for this situation. So then if we go back, my calculator class inherits from this demo interface, implement that method, and then I think actually in this particular case I was playing around to see what kind of warnings and errors I would get. So in this case, this shouldn't be here because it's actually pulling in that contract requires from that other abstract class. So.
And it's going to merge that code into the MSIL of the code is called?
Yes. Yeah. And actually it'll merge it in for every class that's inheriting from that interface. So in a way, how that helps you out is I can define this on the interface one time to say this particular method requires something, And 5 classes can inherit from me and gain the advantage of having those contracts set.
Cool part about that one is you spec an interface and you have now spec the contract to be enforced in the interface besides just saying here's what we're going to do.
Yeah.
You now must do it to satisfy it.
Yeah. And I think that's kind of why they kind of have the rule where the static checkers kind of come along and checking to see, did you put this at the highest possible level? Because otherwise I can't prove that what you're trying to require is going to always hold true.
It's a shame they couldn't make this all attribute driven. I know there's limitations of metadata and whatnot. That seems that would be the nice where you can just do all the code contract with attributes.
It's
On
like
the
teasing
interface
into
itself.
it.
Yeah.
If you notice, it's getting close.
You mean like on the interface itself? Or?
Yeah, like basically just decorate with attributes.
Yeah, what if you have like 20 of them?
I know there's like base level language limitations that are
Right, yeah, I think the problem with that is you can't put
it's
code
metadata
in
only.
there.
Yeah.
You and your code first stuff.
Good.
Because that's more declarative. The if else end would be even more declarative if you just almost have.
Throw some attributes, keep it out of the code, just say here's all the stuff it's going to do. If you put it on an interface, ooh, that would be cool.
Sorry.
Well, if somebody from Microsoft might watch this beautiful presentation, take that suggestion, and they'll run with it. So we can only hope, right?
Tell Anders to move everything else aside.
Everything aside, work on this. Okay, the runtime checker. As I was going through some of the blogs and some of the documentation for the code contracts, I came across this nice little flow chart. So I thought I would include it in our presentation. What it helps you do is, basically what that requires T exception kind of seems to kind of throw in that little stipulation that you have to have the runtime checker turned on. So what this does is it kind of helps you define, when I go into release, do I want the full contract argument validation in my release code? Do I want the runtime checker to go through and modify my MSIL with all this contract code? So basically we run down and we say, well, no. Then he says, well, usage 1 is just to use the plain requires everywhere and just enable runtime checking on your debug builds only. So when you're debugging, then you can take advantage of all the requires, make sure everything's working okay. But then when you actually switch your configuration to release, then none of that require code will get stuck in with your release build. But let's say we do want to include that validation. So it says next thing is, well, do you want to use this runtime checker tool in your release build? And if you say no, this kind of goes back to kind of where I started in my presentation, where I said, sometimes you might want to keep that if then throw logic in your code rather than transforming it into the contract requires. So usage 3 would be supporting that particular method where you're not using the requires that throws the exception. And basically it says, to mark those legacy with that end of control block so the static checker can still give you some benefit out of checking your code. And just like with usage 1, use requires everywhere just in your debug configuration. But if you want to go full on code contracts, you want usage number 2. So you're saying when I go release, I want it to rewrite my MSIL and stick all that stuff in, and that's when, as we can see here right up top, we can use the requires T exception on the public service methods. Requires everywhere, need to make, and the big stipulation here is make sure that for every configuration you've turned on that runtime checker, because he will let you build with it turned off, and you won't know that you made a mistake until you got it deployed. So that's a little big red flag to throw out there to make sure that you're double checking all your stuff. And I guess actually to note that too, if I put this kind of code in my code base, even in debug mode, and somebody else comes and grabs my code to work on it and they don't have the dev lab stuff installed, does not have the runtime checker installed, they're going to get this same assert failure. So if you're going to start using code contracts, you need to make sure anybody on your team that's going to be working with your code needs to be on the same page as you are. Otherwise, they'll be getting some weird errors, and they may not know what to do with them since they don't know what you're doing. One of the runtime checker options basically asks you what level of the runtime checks you actually want to use. And I found this handy-dandy chart in the DevLabs documentation, and just kind of shows you if you go full on, it's going to turn on all legacy. Dang it, I can't click. I'm trying to highlight here. So it'll go full on legacy, all the required, check all the insurers and variants, any asserts or assumes that you've put in your code. If you select pre and post, you can see it starts to kind of dial back the options then. And for the runtime checker, then you can even set it to say none, and it won't check any of that stuff when it builds your code. When to use code contracts? I'm currently experimenting with it a little bit in a project that I'm working on. I'm actually currently writing a WCF service. It's going to be consumed by one of our customer care sites. So I kind of feel that anything you write that's going to be consumed by somebody, maybe even outside of your department, maybe even outside of your company, would probably be a good candidate to use code contracts. Just the benefits the static checker gives and the extra warnings and helping you protect your code can really reduce the amount of errors that somebody consuming your code is going to hit. And, you know, hey, if everything goes well, you wouldn't even have to worry about support tickets, and you could throw something out there and just do new development. So, I know, pie in the sky, you know. I can dream. So this kind of hits the end of my presentation. Once this gets posted, you can see some of the references where I got some of my information. The one that I'll point out to you is this very last one, which was one I came across just the other day that kind of helped me solidify some of the concepts that I was working with, is this Dev Journey blog. And I think he's currently got 6 or 7 chapters in, and he's still got a few left to do. And it's been a really great read, in my opinion, so I kind of recommend this. If you're going to visit any of these links, that would be the one that I would go to get more information and just have fun with it. That's all I can say.
Well, if there's no more questions, I'd say give Mike a hand.
Yeah.